Okay, good morning. Welcome to Math for Kids number
71.
71. You know, believe it or not, this is going to be the last math video for the whole year.
Why? Why would this be the last one?
For the whole year. Because the year ends over the weekend.
Awesome.
Yeah, awesome. We made 256 different math videos. Can you believe that?
So far.
So far, yeah. Maybe next year we'll make even more. Okay, so yesterday in our MoEMS book we ran across a problem about factorials. Okay? And we didn't know what factorials were, so today yesterday I taught you about them a little bit, and today we're going to make a video about factorials. And we're going to have our little Lego minifigures also play a role in this video. But for now, the Lego minifigures are going to stand over to the side. So factorial is kind of a funny thing. I'm going to just write it with an example. 6 factorial. And that's how you write factorial. Instead of writing out the word factorial, you put an exclamation point. So how do you think you would read that, Nor if you were not doing math?
6!
Yeah, it wouldn't just be should. It'd be 6! But that's not what it means in math. It means actually something really specific. It means 6 times 5 times 4 times 3 times 2 times 1. And 5 factorial means 5 times 4 times 3 times 2 times 1. And what do you think 10 factorial means?
10 times 9 times 8 times 7 all the way down to 1.
Okay, so it's actually a nice short abbreviation for kind of a long operation. And the problem we were talking about had 30 factorial, which is a huge number, right? And there's no way you could multiply it all out. So we were learning some kind of fun properties about factorials. But let's see what we can learn about factorials quickly. What's the first thing we notice about factorials? Okay, 1 factorial is just 1. 2 factorial, which is 2 times 1 is
2.
3 factorial, which is 3 times 2 times 1 is 6. 4 factorial, which is 4 times 3 times 2 times 1 is
24.
24. 5 factorial
Is actually 120.
Which is 5 times 4 times 2 times 2 times 1 is 120. 6 factorial.
And 6 times that is 720.
720. So they get big really fast, factorial. So again, you can only imagine how big 30 factorial was. Remember we computed it out in Mathematica and it had what, like, it was something non-nillion, wasn't it?
Yeah, it was 9 million.
9 million, it was a huge number. So it's actually kind of neat that you can multiply these numbers out, but what are they used for is the interesting question. So I'm going to show you 2 things that they're used for. 1 you can understand, and 2 is just kind of for fun. Okay, you ready?
Yeah, with Lego guys.
Yeah, with Lego guys. So we're going to have to remember that 1 factorial is 1, 2 factorial is 2, sorry, I'm covering up, 3 factorial is 6, and 4 factorial is 24. Okay? So one thing you use them for is to count the number of ways things can be arranged. Okay? So if I take 1 Lego minifigure, how many different ways can I arrange this in order, if order matters? I have 1 Lego minifigure. How many ways can I arrange it?
Only one way.
Only one way. What's this guy's name, by the way?
Wolfpack Clone Trooper.
Okay, so this guy's W. Okay. Now, when I have 2 Lego minifigures, how many different ways can I arrange them?
2 different ways.
That's one way.
And flip.
And flip. When order matters, you can arrange them 2 ways. No, 1 factorial is 1, 2 factorial is 2, but this might just be a coincidence because there's lots of sequences that begin 1, 2. Anyway, what's this guy's name?
Obi-Wan Kenobi.
Okay, so this guy's O. So the 2 ways of arranging these guys are WO and OW.
OW are the first 2 letters to my brother's name.
Whoa and O. Okay? Now what about 3 guys? So let's bring this guy, let's bring this Lego guy in. What's his name?
Commander Cody. All these guys have long names.
Commander Cody. So let's just call him C. Oh, this will be funny actually.
What?
Okay, so now we have to figure out all the ways to arrange 3 Lego guys when order matters. So let's go ahead. So here's one way, and what's this guy's name?
Commander Cody, C. Obi-Wan Kenobi, and Wolfpack Clone Trooper.
Okay, so here we get one arrangement, C-O-W.
Cow.
Cow. Okay. Now we have to figure out another way for an easy arrangement. And the easiest way to start counting the arrangements is let's leave Commander Cody as being always first. Okay, so here's another arrangement, which is CWO. Okay, now can we do any more arrangements with Commander Cody first?
No.
No, okay, so let's pick someone else to be first now. The O guy. So this arrangement is OWC, right?
Yeah.
Okay. All right. Are there any more?
You can do WOC.
Well, let's focus on having this guy stay first. Okay, and then you flip them. Okay, so what is this arrangement?
This is OCW.
Okay.
And now we have to put this guy first.
Okay, now we haven't done any with this guy first. Well, actually, let's leave Obi-Wan first for a second. Can we do anything more with Obi-Wan being first?
No.
No, we can't. Okay.
So I have to do Mr. Wolfpack guy first.
Okay, Wolfpack guy. Okay, so what is this arrangement?
It's WCO.
WCO.
And then WOC.
WOC.
It's the exact opposite of cow.
Yeah, it's the exact opposite of cow. But here, when we're talking about these arrangements, we have to remember that order matters. Okay? Order matters. So we found 6 arrangements, which just happens to equal 3 factorial. Okay? And the reason is that when we're trying to find these arrangements, we have 3 choices for the guy who's going to go first. We can pick any one of the guys to go first. And once we've picked one of the guys to go first, how many choices do we have for the guy who goes second?
2.
2. So there's 3 times 2 times, and then once we have that, how many choices do we have?
1.
1. 3 times 2 times 1. Now we're not going to list all the ones out with 4, but as a good challenge problem someday, you could try to write down, try to arrange all these guys.
With little action figures.
Yeah, so what's this person's name?
Ahsoka Tano.
Ahsoka, so we'll call that A. So, you know, this arrangement here would be A, this is W, right?
Yep. O. C.
And then we could find other ways to arrange them. If we always counted all the ways with Ahsoka being first, notice we have 3 guys. And how many ways can we arrange 3 people? We already figured that out.
6.
Okay, so with Ahsoka going first, there's 6 arrangements. And then with anyone else going first, there's also 6 arrangements, and there's 4 people.
Yep.
So we're gonna have 4 times 6. But I'll just leave that as a challenge problem.
Here's a funny one. It's ACOW, a cow.
Okay, so this is a cow. Right? This is a cow. Look, there's a cow. All right, that's kind of funny.
That's funny.
Okay, so you could count all the arrangements that you could make with these 4, and then you would get 24 of them. So that's one way that factorials come in when you're counting things. But I'm going to show you another way that's just kind of fun, and you're going to learn about a new number that you've probably never heard about before.
It's not pi.
It's not pi. Okay. The other interesting thing about factorials is there's a really important number in math called E.
Isn't that in the equation E equals mc squared?
No, that's a different E. This is the math E. That equation you're thinking about, capital E.
Is energy equals mass
Times, you remember what C stands for?
speed of light.
Right, energy equals mass times the speed of light squared. That is a different E. This is the math E. It lives down the street from that other E. Okay? And E is defined to be triple equals 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus ... You have to add up this infinitely long sequence of inverse factorials.
How are you supposed to add up that?
Well, that's why I said you've never seen this before and it's pretty hard. But 1 plus 1 over 1 plus 1 over 2 plus 1 over 6 plus 1 over 24 plus ... plus 1 over 120. And what this turns out to equal, when you learn how to add this up, is about
Approximately equal
2.71828. I think it's 1845 after that, but 2.71828. So it's between 2 and 3. And E is one of the most important numbers in math. But it takes a little bit longer to learn about E because E has some really, really fun properties. So Here's another number you've never learned about before, and it's part of one of the most amazing equations in all of mathematics.
What is that equation?
Are you ready for this?
What?
This is one of the coolest equations, but it's going to take a long time to teach you about this. But it has all the most important numbers in math in one equation. You ready to see this?
Yeah.
So you know about the number 1, right?
Yeah.
You know about the number 0.
Yeah.
Now these are important numbers, right?
Yeah.
You know about the number pi, right?
Yes.
You just learned about the number e.
Yes.
And you learned about, I've taught you also about the imaginary number I.
Yes.
Right? And here's an amazing equation that has all of these numbers in it. Are you ready?
Yeah.
It turns out that e to the power of pi times I plus 1 equals 0.
Whoa.
Whoa. Can you believe that?
What in the world is pi times I?
I don't know. It's hard to even understand what e is. It's hard to understand what pi times I, imaginary pi. E to the imaginary pi power plus 1 equals 0. So that's one of the most important. So you have these 5 numbers, the imaginary number pi, e, 1, and 0, and they all come together to form this amazing equation. And this is one of the really most beautiful things about math.
I think this should equal -1 plus 1.
It's right, e to the pi I equals -1, right?
Yeah.
So e to the pi I plus 1 equals 0. So that gives us all those 5 numbers all together.
Whoa.
Whoa. So
That is awesome.
yeah. It'll take a little bit while to learn about this, but I just wanted to show you that because e is one of the most important numbers and it comes from factorials.
Cool.
Actually, one of the things it comes from is factorials. All right. Good job. That was a fun video for the last video of the year.
Yep.
All right.